Hey everyone, in this video we're going to be talking about angles, and specifically for 8th grade geometry, we're going to be talking about parallel lines and transversals. And I want to review a couple things before we start that you hopefully should have learned in 7th grade, and if you didn't, hopefully this quick review will catch you up. So angle measures are where we have two lines, let me get my pen working here, two lines that come together at a point. Okay, we usually name an angle with letters, 3 of them, A, B, C. You name the points, and we could call this, we would write it angle A, B, C. And what we're measuring in an angle is the amount of rotation from the first line to the second line. And we measure this in degrees. And to measure it, we use a protractor. So if I were to take this protractor right here and move it up, and since I can't rotate my protractor very well, I'm going to rotate, let's see if I can rotate this shape here. Get that flat, and I'll pull my protractor over, and I'll line up the dot and the bottom line. And you can see here when using this protractor, this line crosses at about 40 degrees. So we're measuring this rotation between the two lines, and in this case, our angle is about a 40-degree angle. An angle that most of us are familiar with, I'll draw this one in blue, is a 90-degree angle. Oh, that wasn't a very good line. Let's try that again. A 90-degree angle, which just goes straight up and down like this. And we usually denote that by making a little square in the bottom corner of the angle. So let's talk about 90-degree angles for a second. I'll draw one of those again. When you see one that looks like this with a rectangle, we know that this is a 90-degree angle. And you may have heard the term complementary angles. Complementary angles would be two angles that together form a 90-degree angle. So let's put some points on these. Let's say I have A, B, C, and D. I could say that if I knew that angle ABD was 90 degrees, I could say that angle ABC and angle CBD are complementary angles. Complementary angles add up to 90 degrees. So we could write that out like this: angle ABC and angle CBD are complementary. Okay, so angle ABC and angle CBD are complementary angles. And you may also recall from previous years that a straight line like this, I'll put some dots on here. Let's say we have A, B, C, and D. If we know that ABC is ABD is a straight line, straight lines like that are 180 degrees. So this entire angle measure here is 180 degrees. That would mean that angle ABC and angle CBD add up to make 180 degrees. And we call those supplementary angles. So for example, angle ABC might be 120 degrees. And if ABD is a straight line, we know that it has to be 180 degrees. So its supplement would be 60 degrees. CBD would have to be, this angle here would have to be 60 degrees, because 120 plus 60 makes 180. So we could say angle ABC and angle CBD are supplementary angles. All right, so we know angles that add up to 90 degrees are complementary angles. Angles that add up to 180 degrees are supplementary angles. You may also recall that when two lines cross each other, opposite angles are the same. So these red angles would be the same, and these green angles would be the same measure. We call these vertical angles. Vertical angles. Vertical angles are equal to each other, equal in measure. And the last piece of review here is that when angles like this all share a vertex in the center, if we were to go all the way around this entire circle, this would add up to 360 degrees. So angles that share a vertex in the center like that, and you can go a full 360 degrees around, that's another important thing to remember. So 90-degree angles are complementary, straight lines are supplementary, they add up to 180 degrees, and then all the way around angles that share a vertex in the center, it adds up to 360 degrees, and vertical angles are angles across from each other when two lines cross, and vertical angles are equal to each other. Now let's jump into the 8th grade part of this. When we have parallel lines, so let me find some more space here. I'll see how well I can draw parallel lines. When we have parallel lines, that's two lines that go on and on forever and never touch, and we can show that by giving them these symbols here, these arrows, which tells us that these lines are parallel. And if I were to cut this set of parallel lines with another line like this, we call this a transversal. So I have parallel lines here that will never touch, and I have a transversal. And let's put some letter labels on these. We'll say A, B, C. I'll put one here, D, E, F, G, and H. So what you'll notice here is that I have two spots where my lines cross. One spot is right here, and the other spot is right here. And what you'll notice is those look almost identical. Because of the fact that these lines are parallel, they're going to hit this transversal at the exact same angle. And so these two yellow boxes, our angle measures within those boxes are going to be exactly the same on top and on bottom. Now, if we knew just one of these angle measures, we could figure out all of the other angle measures. So let's take a look at that. Let's say that I were to say that this angle right here was 130 degrees. Well, we talked about vertical angles right here that when two lines cross, opposite angles have the same measure? Well, if we look over here, here is an opposite angle with two lines crossing. So we can say that this angle here is also 130 degrees. So angle ABC and angle FBD are the same measure. Now we can also see that ABD, this one here, is a straight line. And what that means is that angle ABC, our original angle, and this angle here, CBD, are going to have to add up to 180, right? We have supplementary angles there. So we can take 180 and subtract 130, which is 50, and we can find that this angle will be 50 degrees. And then we can see here on this line, whoop, that was not drawn very well. On this line here, again, they're supplementary angles, and we can see 50 and 130. Those do add up to 180. Now, we have another vertical angle here, right? Two lines cross, and the opposite angles are the same measure. So we can say that this angle is 50 degrees. And if we know the angle measures in the top box, because these lines are parallel, the transversal is going to hit the bottom line at the exact same angle as it does on the top, which means that our acute angle here is also going to be 50 degrees, and its vertical angle is going to be 50 degrees. And then this angle here, our obtuse angle, as a review, obtuse angles are greater than 90 degrees and acute angles are less than 90 degrees. So this obtuse angle here is 130 degrees and its vertical angle is going to be 130 degrees. So what you'll notice here is that every one of these angle measures is just one of two measures. It's either 130 or 50 in this case. Now, there's some fancy names we can use to explain why angles have the certain relationships that they do. What you should notice is that any red angle and any blue angle here are supplementary angles. That means they add up to 180. So it doesn't matter which line you're looking at. Any red angle, any blue angle, they're going to add up to 180 degrees. Now you're also going to notice that when we have angles that are in corresponding positions, meaning that they're in the exact same spot on either the top set of angles or the bottom set of angles, they're going to have the same measure. So corresponding angles would be like this 50 here and this 50 here. Both of them are in the bottom left side of, the bottom left corner of our four angles. So they're in corresponding positions. That means they have the same angle. Corresponding angles have the same measure. Other corresponding angles would be like this 130 that's in the top left and this 130 that's in the top left. They are in, put some green dots here, they are in corresponding positions on the same side of the transversal. I have the exact same thing on the other side. This 50 and this 50 are in corresponding positions. They're both in the top right, same side of the transversal, and both above the parallel line. And then I have these 130s down here are corresponding angles. So let's move off to the side here, and we can say that corresponding angles are angles that are in corresponding locations in each set of angles, and they have the same measure. Now, the next relationship that we're going to talk about is something called alternate angles. Let's see if I have I'm getting kind of messy with my colors here. I'm going to use green arrows for this. So if I have alternate angles are on opposite sides of the transversal. So let's use this 130 here and this 130 here. You'll notice one is on the left side and one is on the right side of the transversal. And these angles are interior angles, meaning they are both inside of the parallel lines, not outside of the parallel lines. We call these alternate interior angles. So this one here and this one here are alternate interior angles, and they have the same measure. And let's see, I'll use black for this one. This angle measure here and this angle measure here are also alternate interior angles. They're on opposite sides of the transversal and inside of the parallel lines. We also have alternate exterior angles. I'll use yellow arrows for this. So this one here and this one here are on alternate sides of the transversal, and they are exterior of the parallel lines on the outside, and they have the same measure. We call these alternate exterior angles. And let's see, I'll use blue for this one. This angle measure here and this angle measure here are alternate exterior angles, opposite sides of the transversal, and these ones are outside of the parallel lines. So let's move back over here, and we'll say alternate interior angles are angles that are on opposite sides of the transversal, but inside of the parallel lines, and they have the same measure. And then alternate exterior angles are angles that are on opposite sides of the transversal, but are outside of the parallel lines, and they have the same measure. So we know corresponding angles, we know alternate interior angles, we know alternate exterior angles. And these are fancy ways of all saying the same thing, that angles in certain positions when parallel lines are cut by a transversal are equal to each other. Now, it's great if you can remember those names and relationships, but if you just remember that whenever parallel lines are cut by a transversal, we only have two different angle measures, and you can take a look at it and figure which ones look the same and which ones look different. That should be a good starting point. Sometimes the angles can look very similar, and it's hard to differentiate the obtuse angle and the acute angle, but I think you could always draw this scenario out on the side of a piece of paper and quickly remind yourself which angles are equal and which ones are not equal to each other. But the ones that are not equal to each other we know are supplementary. So let's practice with this for a minute. Let's go down here, and I'll draw some more parallel lines. This time, oh, that wasn't good. This time, we'll make our transversal go this way. And I'm going to give these angles numbers. So let's use 1, 2, 3, 4, 5, 6, 7, 8. I'm going to, in blue, circle two corresponding angles. Well, we could say that 2 and 6 are corresponding angles because they're in the same position, the top right, of each of these two sets of angles. And corresponding angles have the same measure. I could also say, let's use green for this one, and we'll do alternate interior angles. So 4 and 5 are alternate interior angles. They're on opposite sides of the transversal, but inside of the parallel lines, and these ones are equal to each other. We could have also used 3 and 6 as alternate interior angles. Let's take a look at alternate exterior angles. I'll do this one in yellow. Alternate exterior angles would be like 1 and 8. They're on opposite sides of the transversal, but they are outside of the parallel lines, and they have the same measure. Now, we could also say that any of these two numbers that form a line add up to 180 degrees. So 1 and 2, angles 1 and 2 add up to 180 degrees. Angles 1 and 3 add up to 180 degrees. We could also say angle 1 and angle 7 add up to 180 degrees. Even though they're nowhere near each other, they don't appear to form a line, but if we know that angle 1 and angle 5 are corresponding angles, that means angle 5 is the same measure as angle 1, and we can see that angle 7 and angle 5 form a straight line. So we could say that angle 1 and angle 7 would also form a straight line in our supplementary angles, thus adding up to 180. So let's practice with some actual numbers here. Let's make parallel lines again. This time I'm going to make my parallel lines like this. And here's my transversal. And I'm going to make this angle right here be 113 degrees. Well, right away we can find a set of corresponding angles. So this angle and this angle are corresponding. That would make this one 113 degrees. We also have vertical angles here. Our vertical angles are across, so these angles here would also be 113 degrees. 113 degrees. We can double check this. We can see that our alternate interior angles are the same and our alternate exterior angles are the same. That looks like it works nicely. Now we can also find, because we know that these angles are supplementary angles if they form a straight line, this red dot here is going to be 180 minus 113, which is going to equal 67. So 67 degrees would be this angle here, and I have a corresponding angle down here. I also have an alternate interior angle here, or I could have set a vertical angle, right? We can fill these in 67 degrees. So these aren't terribly hard to remember. You just have to remember that there's two different angle measures and which ones are which. But once you have one angle measure, you can find the other 7 angle measures and have all 8 angle measures when parallel lines are cut by a transversal. Now this can get even more fun where we could have algebra. So let me give an algebraic example here. I'm going to draw parallel lines here. Not perfect, but I'll make these lines to note that they're parallel. I'll draw my transversal here. What if I were to have something that looked like this? 2x plus, let's say, 25. And this one will be, we'll make this one down here 4x minus 75. So we can use algebra like this, and we can try to find x and then also find the measures of these angles. So if I know that this angle here in red, this angle here in red are two of my angle measures that I sort of have here, but they're written in algebra with a variable. Well, I like to quickly take a look and find all of my angles that correspond to each other. And I just switched these into different colors. But we can see here that 2x plus 25 and 4x minus 75 are alternate exterior angles. They're outside of the parallel lines, and they're on opposite sides of the transversal here. And so we know that these angles are going to be equal to each other. So we can just make an algebraic equation and say that 2x plus 25 is equal to the other angle measure, which is 4x minus 75. Now we're just solving for x. So I can subtract 2x from each side to get my variables on the same side. That cancels out on the left, and I'm left with 25 is equal to 4x minus 2x, which is just 2x minus 75. Now I want to get x by itself, so I'm going to add 75 to both sides. 25 plus 75 is 100, and that's equal to 2x. Now I'll divide by 2 on each side to get x by itself, and 100 divided by 2 is 50, so x is equal to 50. Now we could use that, x equals 50, and plug it in wherever we see x up here. So if I were to plug in 50 for x here, I would have, let's do it on the side here, 2 times 50, that was not a very good 50, 50 plus 25, 2 times 50 is 100, plus 25 is 125. So both of these angles should be 125 degree angles. Let's double check this bottom one and see if that works. Well, I'm going to put in 50 for x, so I have 4 parentheses 50 minus 75. 4 times 50 is 200. 200 minus 75 is 125. So that worked in both cases. Now, knowing that these angles are 125, we could find the blue angles as well. The blue and the red angles are supplementary angles, so we could take 180 and subtract 125, and we get 55. So these angles, the blue angles, would all be 55 degrees. You could fill that in for each of them, 55 degrees. 55. And then these ones we could fill in 125 degrees. Sorry, my 5s are looking a little bit like 3s. I have trouble writing on the iPad sometimes. So our 125s here, and then our 55s here. Let's try one more of these. Let's do one more with algebra like this. So what if I had parallel lines like this, and they're cut by a transversal, and I know that, let's say I know that this angle down here is 3x plus 7 degrees. That's this angle. And let's say that we know that this angle here is 14x plus 3. Let's try to solve for x and see if we can figure out what each of these angles are equal to. Well, let's start out with seeing what we know. We know that this angle and this angle are alternate exterior angles. We know that this angle is a vertical angle of it and would be the same measure, and same with this one. We know that this angle here, the red one, would be the supplement to this 3x plus 7. So those would add up to 180 degrees. And we have vertical angles. From this one here, we have an alternate exterior angle. And we have another vertical angle across here, or from this spot, it's an alternate interior angle. We've come up with all 8 of our angle relationships here. So we have our blue angles and our red angles. And we'll see here that what we have is a blue angle, 3x plus 7, and we have a red angle, 14x plus 3. These angles are not going to be equal to each other, but we know they are going to add up to 180 degrees. So let's write that out. 3x plus 7 plus 14x plus 3 is all equal to 180 degrees. Now we can just solve. So I'm going to combine my 3x plus my 14x, and then I'm going to combine my positive 7 and my positive 3. So 3x plus 14x is 17x, and then 7 plus 3 is 10, so plus 10 is equal to 180. Now I want to solve for x, so I'm going to subtract 10 from each side to isolate my variable, and I have 17x equals 170. And now I need to divide both sides by 17 to get x by itself. 170 divided by 17 is 10. So we can see here that x equals 10. Now we can go back up and we can plug in 10 for each of these x's here. Let's start on this one on the bottom left. So I have 3 times 10 plus 7. 3 times 10 is 30, plus 7 is 37. So we can see that the blue angles are 37 degrees. And then over here, I have 14x, or 14 times 10, plus 3. 14 times 10 is 140, plus 3 is 143. So our red angles are 143 degrees. And our red and our blue should combine to make 180, which these appear to. 37 plus 143 is 180. All right. So it's great if you know the different terms, corresponding angles, alternate exterior angles, alternate interior angles, vertical angles, supplementary angles, even complementary angles. Those are all important terms to know. But with parallel lines and transversals, if you can just remember that we have two different sets of angles here, and that our angles add up to 180, the ones that are not the same as each other, visually, this is pretty easy to see and remember. One other piece to remember here is that if we were to measure all the way around this, it should add up to 360 degrees. Let's try that really quick. We know that we have 143 degrees on this one, plus another 143 degrees, and then we have 237 degrees. So let's try to add all of this up. So 7 plus 7 is 14, plus 3 is 17, plus 3 is 20. So I have a 0, carry my 2. 2 plus 4 is 6, plus 4 is 10, plus 3 is 13, plus 3 is 16. Put down my 6, carry my 1. 1 plus 1 plus 1 is 3, and I do get 360. So we can see how these angle relationships work with each other. And really, these turn into some pretty fun puzzles to try to figure out how all the angles relate and use algebra or just numbers to try to solve for the missing angles. There can be some really complex puzzles like this that are a fun challenge to try to figure out. So with that said, I'm going to turn you loose. As always, if you have any questions, reach out and let us know, and go ahead and get started on your practice for today. I'll see you in the next video.